Okay, so here is a free response question from 2014, and it's number 3, so it's no calculator. Again, the idea on these is that you've already worked it through and that you're going to track through kind of my explanation of it, and I'll put scoring points on it as well. I'll try to talk through some alternative solutions or ways you could word things. The reason I chose this one is fundamental theorem is a really repetitive question that they ask, so it comes up almost every year. And for the last several years, it's come up every year. This one's a little more varied, though, and has enough pieces to it that I think it's going to be a good indicator of maybe the way they're going to ask a question this year. So that being said, points are going to be heavy on process and less about result, but there will be some result points. So they're giving you a graph of a function of f. So they're giving you a graph of f, and then they're defining g to be the integral. So they're defining g, that's right up here, let's see, to be an integral. So if g is an integral, and I'm going to write this over to the side, and you're certainly welcome to do this when you take the exam. You don't have to, but it helps me organize my thinking around it, and I don't know, I think it's beneficial. So if g is the integral of f, if I take the derivative of both sides, g prime then is f. And if I take another derivative, g double prime, or second derivative of g is f prime. This set of stuff, I'm going to use some or all of it. I don't know how much based on what the question's asking, but it's going to relate to this concept. Okay, so let's see. First off, we are asked to find g of 3. So g of 3. G of 3 means if we put 3 in to the integral expression, so let's see, I'll do that right here. So I put 3 in, so g of 3. Take x out, put 3 in. So it's negative 3 to 3 f of t dt. So here's my graph of f. From negative 3 to 3, I'm going from right here over to right here. So I'm going to be looking at a positive triangle as well as a negative triangle. So there's this positive triangle. There's this negative triangle. You can break up the positive triangle into two 90s or two right angles, or you could do one solid triangle, half base height. Doesn't really matter. It's really whatever you're most comfortable with. If I look at that as one big triangle that's up top, which it is, it would have a base of 1, 2, 3, 4, 5. So that's a base of 5. So it'd be half times base times height, which would be 1, 2, 3, and 4. So I've got half times 5 times 4, so that part's 10. So that area right there is 10. And then I've got this negative space, so my negative height that's associated with the value of 3. So I'm going to have to figure out what the slope is to get what that height actually is, but the base on this is just going from just one unit. So it's half times a base of 1 times a height of whatever that amount would be associated with the triangle right there. So let's see, if I look at this thing, I'm going from, it's a linear segment, so I'm going from 4 down to 0, and that's taking me 2. So this thing has a slope of negative 2 the whole way, which means if I move from 0 1 unit over, that height is a negative 2. So I've dropped 2 in with a run of 1. So my height is going to be a negative 2, meaning my negative space on that triangle is half times 1 times negative 2, so that's a minus 1. So my overall answer is going to be 9, and that gets tagged 1 point. That's it. So we've got a positive 10 and a negative 1 for our space. Sometimes they associate with showing work. This time they're just saying, here's your point. You got 9. Part B is saying on what open interval from negative 5 to 4 is the graph of g both increasing and concave down. So if we're looking for increasing and concave down and then giving a reason, this one has 2 points, one for the solution and one for the reason. Here's where I'm going to bring this back into play, so this table over here. So specifically, actually, I'm going to star in on the fact that g prime is equal to f. So where g is increasing is where g prime is positive. So that's where f has positive values. And that happens all the way from negative 5 over to 2. So all the way from negative 5 to 2, with the exception actually of negative 3, right? So that one, it's at 0. But that whole span from negative 5 to 2 has positive values with the exception of negative 3. So that would be where the graph is increasing because the first derivative is positive. But then we also need to know where it's concave down. So concave down means we're looking at the second derivative of g. Well, the second derivative of g is f prime. In other words, we're looking at the slope of this graph. And if we're looking for concave down, we want to know where f prime is negative. So concave down, I want to know where f prime is negative, and that would equate to G double prime. Well, the slope on this thing is negative from -5 to -3, and then again from 0 to 2. And so my answer on this is going to be -5 to -3, and then 0 to 2. And you can write it this way. You could write it with the brackets like this. That would also be okay. And so on those intervals, you are going to be both increasing and concave down for the graph of G. And the reason is that, so I'd say because G prime equals F, and F is positive, and that indicates the first derivative of G is going to be positive, and decreasing. So F is both positive and decreasing on those intervals. And you could also say that you could also make the second derivative argument. So you could say G double prime is F prime, and you could say the derivative is negative. I'm using the term decreasing and linking it to F, and that actually is the way the scoring guide puts it. But you could also say that G double prime is equal to F prime. And then so instead of using this word decreasing, you could say this first part, but then you would say the second part where the F prime is a negative value, and that would be okay as well. So that explanation then nets a point, and the correct interval nets a point. Okay, so now we're going to look at C and D, and I'll scroll back up here and I'll figure out a way to get this to show up. So we've got C and D. So we've got the function is defined, this H function. This is actually why I chose this particular question, was because they branched out from just the standard way of asking it, and they threw in a couple kind of auxiliary pieces, which I think is going to be how the test feels this year, is going to be like this. But again, it's a bit of guesswork on my part at this point, as it is for anybody, because it's so different this year. But you know, they're defining this function, and they're asking you to find a derivative. They're going to give you 2 points for process and 1 point for product for result, and then they're going to do the same thing on D. And we're going to bring in the information from the picture, but we're going to have to show some steps. So we've got h of x is equal to g of x over 5x, and we're finding h prime. So g of x, so h of x is defined as g of x over 5x, and what we're looking to do is find h prime of 3. So that's what our target is. So let's see, to actually take the derivative on this thing, I have to use quotient rule. So this is a nice way for them to force quotient rule. So you're going to go low, d high. So 5x times g prime of x minus high, g of x, d low, so times 5, all over low squared. And I'm going to write that as 5x quantity squared. So this is the derivative of h, and it's using the quotient rule. You're going to plug in a 3, so what we're actually after is putting a 3 in here. But the act of taking the derivative itself gets 2 points tacked onto it. So it might seem small, but they're looking for process here. And then we're going to take 3 and plug it in. So it's going to be 5 times 3, so that's 15, times g prime of 3, and we'll get back to that in a moment, then times g of 3 times 5, all over 5 times 3, which is 15 squared. So let's see, g prime of 3 and g of 3. Those are the two values we need. So we need those off of the graph. So g of 3 and g prime of 3. Well, let's see. If I want g of 3, I already actually found g of 3. G of 3 was what we did in part A. So you're actually using that 9 that we found in part A. And that's going to sit right here. So I'm going to have a 9 right there. And that's the value we found in part A. And then g prime of 3, you're looking for the slope at 3 for g function. Well, that's this link again that we're using. So g prime equals f. So g prime of 3 is f of 3. Well, what's f of 3? That's right over here. And that actually coincides with the fact that we already did the work on that one. We found that height to be -2. That means the point here that we're looking at is 3, -2. So they're trying to be nice to us by letting us do something with what we already found and not have to redo our efforts. So that is a -2, which means on the top we're going to have 15 times -2, so that's going to be a -30, minus 9 times 5, and well, 9 times 5, that's 45, all over 15 squared, which is a 225. Then we've got -30 minus 45. So let's see, that would be -30 minus 45. So that would be -75 over 225. Technically speaking, that is all you've got to do with it. However, it should be visible that the top and the bottom are both divisible by 25, which would give you a -3 on top. And if we chop the bottom down by 25, let's see, what would that be? That would be a 9, and -3/9 is really just -1/3 in disguise. And you might not see the -1/3 right here, but the 25 should pop in. And if you see that there's a 75 common multiplier, that's great. But we get a -1/3 for our answer, which has a point tagged to it. So again, 2 points for process, 1 point for the actual answer, the actual result. And on this one for D, let's scroll back up. It's kind of a similar deal. They're saying the function p is defined as p of x is equal to f times x, or f of x squared minus x. Find the slope of the tangent line to the graph of p at the point where x equals -1. So we're looking for the slope of the tangent line. So we want p prime, and we're going to evaluate that at -1. So that is telling me we want p prime evaluated at -1. Okay, well, p prime, let's see, if we have p equals f of x squared minus x. So p equals f of x squared minus x. So if I want the derivative, I need to do f prime, leave the inside alone, times the derivative of the inside. So this is them getting at, do you know chain rule? So there, as simple as that might seem, showing that you know chain rule gets tagged as 2 points on this one. And then what we're going to do is actually plug in -1. So it'll be f prime of, let's see, it'll be -1 squared minus 1 times 2 times -1, so -2 minus 1. And again, just taking a -1 and putting it everywhere x shows up. So that's going to be f prime evaluated at, what is this? That's 1 minus 1, so that's f prime of 0 times a -3. So my value, or my answer, for this one is going to be whatever f prime of 0 is times -3. So f prime of 0, I have a suspicion I'm going to have to go back up here and do something. F prime of 0, well, f prime is g double prime. So f prime of 0, that's right here, f prime of 0. So f prime of 0 is up there. And here we've got a graph of f. Well, what's the derivative's value at 0? So the derivative's value at 0 is what we're after here. And something is just feeling wacky about what I'm doing here. Like, it's just not quite computing, because that's a cusp or an undefined point. And that sure feels like they could throw that in there, and the answer could be undefined. I happen to know it's not, so I know that something went wrong. And usually when something goes wrong, and part of the reason I'm leaving my error in here and not reshooting the video is so that you see a mistake. That's important for you to see, and it's important not to gloss over that those happen, and they may happen to you while you're taking the test. And I'm not saying you shouldn't say it. You might get an undefined answer, and that's absolutely fine. But chances are pretty good I made a mechanical mistake somewhere. I'm not seeing it on my first step where I so confidently awarded myself 2 points. That one looks pretty good. I am, though, starting to see it right here. I'm going to get a different color to do it. You know what? Let's grab a highlighter because that's fun. There's my mistake. I need to minus a -1. And when you subtract a negative, that's really a sneaky way of making something positive. So, oh my goodness, look at that. That changes everything. So then this actually isn't 0, it's 2. And that is going to give me a value I bet I can nail down. So f prime of 2. Well, f prime of 2, oh my goodness, we already figured that one out. That's a -2. That's what's happening along this line. So that slope's worth a -2. So we're going to go back in there and we're going to say, okay, we've got it. We solved our issue. It's still time to spare. I'm going to make my change. And I'm going to answer 6. Now, that 6 happens to only be worth a point, and the setup was worth 2, but it's still worth getting, and something just told me that wasn't sitting right. So I went back and looked, and it is possible that they would give you an undefined answer, but it's really, really unlikely. So hopefully that helps to see me walk through a mistake as you would kind of in a classroom setting, and would be much easier to edit out in a video, but I think important for you to see. So those are the 9 points associated with this problem. It's a fundamental theorem problem, but then it branches out and has you show some quotient rule and some chain rule, which I think is a good example of how we might see problems this year.